Sarcopenia is a progressive, age-related disorder that leads to a decline in skeletal muscle mass, strength, and physical function. As people age, especially those over 65, the risk of sarcopenia increases, impacting mobility, independence, and overall quality of life. This condition is not just a natural part of aging, but is also influenced by factors like physical inactivity, chronic diseases, and nutritional deficiency. Consequences of sarcopenia extend beyond muscle weakness, increasing the risk of falls, frailty, hospitalization, and even mortality. With the global population aging rapidly, understanding and managing sarcopenia has become a critical public health priority. In this video, we'll explore how exercise and molecular messengers called exerkins play a pivotal role in combating sarcopenia. As we age, our bodies undergo various changes that affect muscle health. Aging is associated with insulin resistance, chronic low-grade inflammation, oxidative stress, and hormonal imbalances. These factors collectively contribute to the loss of muscle mass and function. Additionally, reduced activity of satellite cells, which are essential for muscle repair, and increased muscle breakdown further accelerate muscle degeneration. Physical inactivity and poor nutrition can worsen these effects, making sarcopenia more severe. The decline in muscle health not only limits daily activities but also increases the risk of chronic diseases and reduces life expectancy. Recognizing these age-related changes is the first step toward effective prevention and management. Exercise is widely recognized as one of the most effective non-pharmacological interventions for managing sarcopenia. Both resistance and endurance training have been shown to induce beneficial adaptations in skeletal muscle, such as increased muscle mass, improved neuromuscular function, and enhanced metabolic efficiency. Exercise also helps correct hormonal imbalances, reduce inflammation, and improve mitochondrial function. Regular physical activity is recommended as the primary approach for preventing and treating sarcopenia, as supported by numerous research studies. But how does exercise achieve these benefits at the molecular level? The answer lies in the fascinating world of exerkins. Exerkins are signaling molecules released by various tissues, including skeletal muscle, bone, liver, and adipose tissue, in response to physical exercise. These molecules act as messengers, mediating the systemic benefits of exercise through autocrine, paracrine, and endocrine pathways. Exerkins play crucial roles in interorgan communication, muscle regeneration, mitochondrial function, inflammation control, and metabolic homeostasis. Their secretion and function are influenced by the type, intensity, and duration of exercise. Understanding exerkins opens new possibilities for targeted therapies, especially for those unable to engage in regular physical activity. Exerkins encompass a diverse group of bioactive molecules including myokines, adipokines, hepatokines, osteokines, metabolites, and extracellular vesicles. Myokines are secreted by contracting skeletal muscles, while adipokines come from fat tissue, hepatokines from the liver, and osteokines from bone. Each type of exerkin has unique functions, but together, they regulate muscle homeostasis, modulate inflammation, enhance mitochondrial function, and facilitate communication between organs. The interplay of these molecules is essential for the beneficial effects of exercise on muscle and overall health. Exerkins are central to maintaining and improving muscle mass, especially in older adults at risk of sarcopenia. They regulate mitochondrial homeostasis, reduce pro-inflammatory signaling and oxidative stress, enhance fatty acid oxidation and glucose metabolism, and promote muscle anabolism. By orchestrating these processes, exerkins help preserve muscle mass and function, supporting mobility and independence in aging population. The discovery of these molecules has revolutionized our understanding of how exercise benefits the body at a cellular level. Apelin is a myokine that plays a vital role in maintaining and enhancing skeletal muscle, as well as supporting cognitive performance during aging. Its production is stimulated by muscle contraction but tends to decrease with age. Research shows that exercise upregulates apelin expression, which helps counteract muscle aging. In animal studies, higher apelin levels improve muscle function, promote mitochondrial health, and enhance muscle regeneration. Apelin also supports bone health by promoting bone formation. These findings highlight apelin's potential as a therapeutic target for diagnosing and treating early sarcopenia. Leukemia inhibitory factor, or LIF, is another important myokine belonging to the IL-6 superfamily. Originally identified for its role in suppressing leukemia cell proliferation, LIF is now recognized for its functions in muscle regeneration and immune regulation. Exercise rapidly increases LIF expression in muscle, promoting satellite cell and myoblast proliferation. LIF also has strong anti-inflammatory effects, helping to control inflammation during muscle repair. By supporting both muscle regeneration and inflammation control, LIF is essential for healthy muscle adaptation to exercise. Allostatin and myostatin are two exerkins with opposing effects on muscle growth. Myostatin acts as a negative regulator, inhibiting muscle growth, while follistatin promotes muscle development by neutralizing myostatin's activity. Exercise reduces myostatin levels and increases follistatin, creating an environment that favors muscle anabolism. This balance is crucial for maintaining muscle mass, especially in older adults. Therapies targeting the follistatin-myostatin axis are being explored as potential treatments for sarcopenia and other muscle-wasting conditions. 12-13-D-HOME is a lipokine released from brown adipose tissue in response to exercise. Its levels rise after a single bout of physical activity, regardless of age or sex. This molecule enhances skeletal muscle's ability to take up fatty acids and promotes mitochondrial beta oxidation, supporting energy production and muscle health. 12-13-D-HOME also benefits heart function and may play a role in metabolic health. Its discovery underscores the importance of fat-muscle communication in the systemic benefits of exercise. Body's response to exercise depends on whether the activity is acute, a single session, or chronic regular training. Acute exercise triggers immediate short-lived changes in exerkin levels, such as spikes in inflammatory and anti-inflammatory cytokines. These responses help maintain metabolic balance and prepare the body for recovery. Chronic exercise, on the other hand, leads to sustained adaptations, including improved metabolic efficiency, reduced inflammation, and long-term upregulation of beneficial exerkins. Both types of exercise are important for muscle health, but regular activity is key for lasting benefits. Duration of exercise significantly influences exerkin secretion and physiological responses. Short bouts of exercise primarily induce transient changes, such as temporary increases in inflammatory markers and fuel utilization. These changes usually return to baseline within a few hours. In contrast, long-term or regular exercise leads to cumulative effects, including enhanced glucose uptake, fatty acid oxidation, and reduced oxidative stress. Over time, these adaptations help preserve muscle mass and function, highlighting the importance of consistency in physical activity routines. Exercise intensity is another crucial factor that shapes exerkin responses. High-intensity interval training HIIT has been shown to elicit greater increases in certain exerkins, such as brain-derived neurotrophic factor BDNF, FGF21, and follistatin compared to moderate-intensity exercise. Higher intensity also boosts anti-inflammatory and anabolic responses, supporting muscle growth and metabolic health. However, the optimal intensity may vary between individuals, and both moderate and high-intensity exercise have their unique benefits. Tailoring exercise intensity can help maximize the positive effects on muscle and systemic health. Aerobic exercise, such as walking, cycling, or swimming, is closely linked to the upregulation of key exerkins like irisin, IL-6, BDNF, and FGF21. These molecules enhance mitochondrial function, increase fatty acid oxidation, improve insulin sensitivity, and reduce inflammation. Aerobic exercise not only supports cardiovascular health but also helps maintain muscle quality and physical performance, especially in older adults. Recent studies suggest that aerobic activity may even have anabolic effects, contributing to muscle growth and regeneration. Resistance exercise, such as weightlifting or bodyweight training, primarily stimulates muscle anabolic pathways. It increases the expression of insulin-like growth factor 1, IGF-1, apelin, and IL-15 while suppressing myostatin. These changes promote muscle hypertrophy, satellite cell activation, and muscle regeneration. Resistance training also improves glucose and lipid metabolism and supports mitochondrial health. Both acute and chronic resistance exercise have immediate and lasting positive effects on muscle strength and mass, making it a cornerstone of sarcopenia management. Combining aerobic and resistance training offers synergistic benefits for musculoskeletal and metabolic health. This multimodal approach stimulates a broader exerkin profile, amplifying muscle hypertrophy, metabolic regulation, and anti-inflammatory effects. Meta-analyses show that combined training is superior to either modality alone in reducing inflammation and improving muscle function. For older adults and those at risk of sarcopenia, a balanced exercise program that includes both aerobic and resistance components is highly recommended. Despite the proven benefits of exercise, individual responses can vary due to factors like genetics, nutrition, environment, and underlying health conditions. Personalized exercise prescriptions that consider the type, duration, intensity, and frequency of activity are essential for optimizing outcomes, especially in older adults with sarcopenia. Ongoing research aims to better understand these individual differences and develop tailored strategies that maximize the benefits of exercise and exerkin modulation. Conditions like type 2 diabetes, obesity, fatty liver disease, and chronic kidney disease often coexist with sarcopenia and can alter exerkin biology. In these states, insulin resistance, chronic inflammation, and hormonal imbalances disrupt exerkin secretion and signaling, reducing their beneficial effects. This highlights the need for individualized exercise and therapeutic strategies that address both sarcopenia and its metabolic comorbidity. Further research is needed to define optimal interventions for these complex cases. For individuals unable to engage in regular physical activity, exercise mimetics, pharmacological agents that mimic the effects of exercise are being developed. These include AMPK activators, myostatin inhibitors, and apelin analogs. While promising, current exercise mimetics mainly target single pathways and cannot fully replicate the broad benefits of natural exercise. Concerns about long-term safety and limited clinical evidence mean that, for now, these agents are best considered as adjuncts rather than replacements for physical activity. Convergence of exercise science, molecular biology, and therapeutic innovation is transforming how we approach aging and muscle health. Advances in exerkin research are paving the way for new strategies to extend health span, not just lifespan. By unraveling the molecular mechanisms behind exercise benefits, we move closer to personalized, effective interventions for sarcopenia and age-related diseases. The ultimate goal is to empower older adults to maintain independence, mobility, and quality of life through science-backed approaches. Summary: sarcopenia is a major challenge for aging populations, but exercise and exercins offer powerful tools for prevention and management. Regular physical activity tailored to individual needs stimulates the release of beneficial exerkins that support muscle health, metabolic balance, and systemic well-being. While exercise mimetics hold promise for those unable to be active, natural exercise remains the gold standard. Continued research and innovation will help us unlock new ways to promote healthy aging and combat muscle loss.